Okay, good evening, everybody. We're back again. It's January 27th, 2016. My name is Bart Cacciola. I'm the host at multi-rotor and we're here with you tonight for another episode of Drone Radio Live. Tonight's episode is a little different from the ones that you've seen us do the last few months. Instead of including news, instead of including our safety or FPV segments tonight, we're just going to stick with our core special guests who are here from Rutgers University tonight. They drove up from New Brunswick. We have Professor Javier Diez and his team of research students. They comprise the design and development team for the NAVIATOR amphibious drone. You might have seen it on YouTube. It was a big hit on the internet back in October. And do we have a picture of the team, Bill? There we go. That's Professor Diez. That's their NAVIATOR drone and 3 research students that he has with him tonight, Marco, James, and Lucas. And they're going to talk about the project. They're going to talk about the parts that they've been working on. And Professor Diez is here with us. He's going to talk a little bit about how the project got started. The first segment we're going to talk about, though, is something new. If you watched the show last night, we did a special segment to welcome show sponsor and multi-rotor forums advertiser, ProAdrenaline.com. And what they do is they are the North American distributor for the ProDad products, the ProDad family of products, which are Respeeder, ProAdrenaline, and ProDad. They're video processing software packages that you could run your video material through. And what they do is they stabilize it, they enhance it a little bit. Respeeder actually takes footage that might have been shot at 60 or 120 frames per second, and it builds the frames to make it look like slow motion done using footage that might have been originally 300 frames per second. So it's really powerful stuff. And one of the things that we talked about last night was this new segment of the show, which is going to be called Pro Aerial Tips by ProAdrenaline.com. And this is Pro Aerial Tip number 1. If you can't control it, constrain it. And that was... That's what my mom said. That was supposed to come later on in the segment here, but Bill's a little fast on the finger tonight. So we're just going to roll right into the pro tip, which is if you can't control it, constrain it. Where that comes from is from when we started multi-rotorforums.com, and I keep going back to the early days when we started. I have my Rutgers shirt on, by the way, just to pay homage to my alma mater and to our guests tonight that are from Rutgers. But anyway, I keep going back to the early days of multi-rotor forums and the early days when drones were not on the news every night. They weren't any better understood or worse back then, but we were kind of in the dark days of stabilized camera mounts. And a lot of us were putting a lot of time. I showed some of these examples last night. This was the MKTR. This was the one I was building. And I didn't really get into some of the funky details about them because I wanted to save it for tonight. Back in those days, these camera mounts were being designed by anybody with a CNC cutter who could buy some G10, draw something on AutoCAD, slap it together. Grommets were the big thing of the day. If you had a box of grommets and some G10, you were calling yourself a camera mount designer. And grommets were not the best thing for vibration isolation, but that's what everybody was using at the time. So me being the host at multi-rotorforums.com, I wasn't just working on my camera mounts. I wasn't just working on my aerial media quality issues. I was also hosting the site, so I got to see a lot of other stuff that the more serious aerial media people might have skipped over. And one of the things I noticed was there were a lot of people building very basic quads. Back in those days, I think it was APM 2.0 or something like that, or 1.5. I don't even know what it was on, but there were a lot of people flying very basic quadcopters with GoPro 1s fastened directly to the frame with a strap of Velcro, and they would just fly it around, shoot some video. And one of the things I noticed back in those days was that the footage, in some cases, was excellent. I mean, it was clear, there was no jello, there were no jitters or shakes. Other than the movement of the helicopter, the footage was awesome. A lot of us with our camera mounts were looking at footage that was jittery. You could see when the helicopter turned or reversed direction, the whole camera mount would load up the soft material that was supposed to be isolating it from vibration. It was loading up that soft material, and as the helicopter reversed direction, that soft material would release like springs, and the whole camera mount would have this ka-chung, like it went over a speed bump or something. So watching the footage with the hard-mounted GoPros, I thought, you know what, I'll bet you this thing that we all do called vibration isolation is a bad idea. And it became like a bad word in my shop. I got rid of all the grommets. Like this camera mount, for example, when it comes to, if you can't control it, constrain it, when you have soft materials that are giving and giving and giving and causing the video to jump around, what you want to do is find where those freedoms of motion are, because your camera controller can't do anything about all those jitters and shakes. So if the camera mount controller, whether it's your brushless controller, your servo-driven gimbal controller, whatever it is, if it doesn't have the power to control the motion of the gimbal, you can't let the gimbal move. So what does all that mean? What it means is a camera mount like this one, and I have some newer stuff here. I'm not just going to show you all my old stuff. But a camera mount like this one, this is the one that I designed, okay? And you can see that it's pretty hardy. And when this was attached to the helicopter, even with the batteries on the helicopter frame, I was able to pick up the camera mount by here and carry the whole helicopter around like it was a briefcase. And this was very rigidly mounted underneath the helicopter, and there's no motion here whatsoever for the camera mount to move around once it's attached. The only way this camera mount can move when it's attached to the helicopter, the only freedoms of motion that it has are motions that are actually controllable by the gimbal controller. So this camera mount wasn't loading up, it wasn't shaking, it wasn't jiggling, because the camera controller can't compensate for any of that. All it can do is roll and tilt. So that's the only way this camera mount should be able to move. When this camera mount was attached to the helicopter, if the helicopter rolled 40 degrees left, the camera mount went with it. It didn't load up and shimmy. It didn't unload as the helicopter rolled level. It was very fixed to the bottom of the helicopter with very minimal vibration isolation, and the footage was awesome. Now, it suffered from all the weaknesses of a servo-driven gimbal in those days, which we all are familiar with, but it didn't have the jitters, it didn't have the shakes, it didn't have jello. So what it had was a minimal amount of servo-driven controller lag, and we were able to fix that using our sponsor's product, actually, which was Mercalli. So we don't have, Philip Hinkle was supposed to join us again tonight. We're having technical issues with our Skype computer. Our new studio manager, Bill, is working the board here, and he's giving me that Phil didn't make it into the studio tonight via Skype. So I apologize, Phil, if you're watching the show, but I got your back. Prodrenalin sponsors the show now. They're sponsoring this aerial tips, this pro aerial tips segment. And so our tip tonight, like we said, let's put that back up again. If you can't control it, constrain it. Now, on a newer helicopter, let's get rid of this stuff, these dinosaurs. On a newer helicopter, right, this is my Iris Plus. And some of you are saying, hey, Bart, that's a pretty old helicopter too. But it's newer. And with this one, it has a Taro 2-axis camera mount on here. And go ahead and get rid of the screen. There we go. So it has this 2-axis camera mount. And if you look at it, looks pretty standard, right? But you can see there's foam on all 4 corners in addition to the little rubber pieces. So the problem with this camera mount and the problem with the mount as it comes from 3D robotics is that if you take this and you do your little study that I'm recommending, if you take that camera mount, it's got freedoms of motion. Now it doesn't yaw, it's pretty rigid in yaw, right? But look at how much it gives in roll and tilt, okay? So if you're flying this helicopter around, you've got the GoPro mounted on there, what's going to happen is as you come across in reverse direction, that soft rubber underneath is going to let the camera mount jiggle. So you see that motion? The camera mount can't compensate for that, so you have to make sure it doesn't happen. And the way I did that with this particular camera mount, I took some foam. This is pick and pluck foam from a case that I had in my basement. I stuffed a wedge of it under each corner. So, very simple. I took it out and flew it, and the video product out of the camera was 1,000 times better. Now, that motion isn't as noticeable. I'm not hard mounting it. I'm not going hard surface to hard surface. That transfers vibration. But what I've done is I've taken a freedom of motion out of the gimbal that the gimbal would never have been able to control, and it would have always plagued the video product, okay? So what you have to do is take your equipment, sit it on the bench, get yourself a coffee, a beer, whatever you want, and just take the equipment, give it a little shove, a little move, find those little freedoms of motion that you didn't know were there, and constrain them. Don't let them happen. Give that gimbal controller a chance to control the only thing that is free to move, which is the gimbal itself, and your footage is going to be great. Prodrenalin has a product called Prodrenalin. That's their hobby grade product. It's about $50 for prodrenalin.com. And you run your software, or you run your video footage through the software, and it gets rid of whatever remaining jitters you might have that are more from the environment you're flying in than from the helicopter itself. And there's their higher end, their pro grade product is Mercalli V4 SAL Plus. And that is something that I used as an aerial media person when I was doing projects. I still would use it today if I was doing more video projects, which I'm not, because I'm much more involved in running the websites and running the show. And actually, until I get a 333 exemption or they do a certification process for commercial ops, I don't think I should be flying, because if it's associated with the show, what do you say, Bill? I think the FAA would give me the big smackdown, right? So that's our pro aerial tip, number one. If you can't control it, constrain it. It's going to make you a better aerial videographer. It's going to get you much better footage. But at the end of the day, get the shot. Don't miss the opportunity to get the shot that's going to make your project. If the footage needs a little help, bring it home, run it through Prodrenalin, and it's going to be muy bueno. Okay? So thank you again to Prodrenalin for sponsoring the show, picking up an ad at Multi-Rotor Forums. We appreciate it. You've got a great product. I highly recommend everybody give it a try. So now, right to our special guest, we have Professor Javier Diez from Rutgers University. Why don't you make yourself at home, get your microphone hooked up if it isn't already, and we're going to talk about the NAVIATOR.
Happy to be here today, and thanks for the invitation.
Yes, very nice to see you. Thank you for coming. This has been something that I've really been looking forward to. I've been in touch with you for probably at least 2 months. And we've been going back and forth with emails trying to find a date that would work for both of us. We had a storm this past Saturday that I thought was going to cause a problem, especially with the narrow side street outside of the studio. But it's ended up working out great.
We survived the storm.
We survived the storm. And just to give everybody a little bit of background information, the NAVIATOR is an amphibious drone. It is made to be able to fly as well as dip into the water and continue to maneuver using a lot of the mechanisms that it would in the air. So you told me before that initially this was just a project that you took on with your research students, and why don't you tell us a little bit about that?
So yes, it started as an undergraduate senior design project. So we usually have a capstone, project for our students. It's usually groups of 5, 6 students. I work on this project for a year. Right. So the idea was to create a vehicle that can fly and go around the water. Mm-hmm. And the initial idea was to use a buoyant system. Right. So instead of having as you see on that video, in the previous video, instead of having a set of propellers, what we had was an inflatable system. So the vehicle was slightly heavier, so the moment it got into the water, it will sink. Mm-hmm. And then you will inflate this system, and it will get you to the surface of the water, and then the propellers will do the rest of the work. So that was kind of a buoyant system. Now
that first version, when it went into the water, you weren't using the propellers trying to maneuver underwater. You were just trying to control buoyancy. Correct. So that it could go down, sensors, whatever, and then go back to the surface and disappear.
That's right.
Cool. Okay.
That senior project was quite successful. They got first prize in the department, and everybody was very happy. Right. So then we kept thinking about how do we make this better.
Was the first project ever a hit on YouTube like the latest version has been?
No.
Okay. Because that's how I found out about you. I mean, you're right around the corner, and I saw it on YouTube and said, wow.
It's unbelievable how when you get 10 million views as an engineer, you go like, wow, do we engineers get that many?
Is that really what it's up to?
It's over 10 million.
Oh my God, I didn't realize. Wow, congratulations. You went viral. I have someone in the studio who accomplished The impossible. Are you guys proud of Professor Diez? Viral, I've never met a person who actually had a viral video. My son's tried it a half a dozen times and it didn't work. So anyway.
It's kind of overwhelming to realize these numbers, but
wow.
So yeah, we just kept thinking, and you're going to meet later on Marco,
right?
Who wanted to continue on the project,
right?
So then we decided to go with a different set of propulsion method, which is what you're going to see later is this set of dual propellers.
Just step a little closer to me, so we're in better view of the camera. If he goes to camera too. Sure, that's fine.
So that was kind of the breakthrough, switch to from a buoyant system to this set of dual propellers.
Wow.
And it worked very well.
Wow.
You think it would be hard, but it was actually relatively easy.
Right. Now, one of the questions, this might be better suited for one of the students that's with us as far as controls go. One of the big questions I have is gains. When hobbyists get together and talk about multi-rotor helicopters, there's always the question of PID tuning, aka gains, and how it affects the flight, the stability. What we don't discuss a lot, which I think is not really understood very well, is that when you take the throttle and reduce it and start trying to descend, the gains that you had for flying and maneuvering aren't quite enough for stabilization when you're underpowered and descending. So you are going from flight in the air, right, to flight in the water. So is there a switch where you tell the helicopter, okay, you're underwater now, whole different set of gains, whole different set of stabilization profile that we have to use?
So we have, I think Marco will tell you a little more about this later, but
sure.
We do have that switch where you can do that. The idea is, like you say, when you throttle, you're underwater, you're going to be at 10%.
You what?
You're at 10% of your throttle.
Oh, it hovers at 10%? Oh, because the water is has so much more mass.
It's actually, we designed the vehicle to be neutrally buoyant.
Right.
So it doesn't sink, it doesn't come to the surface, so it stays around there. So if you want to do any little things, just a very small amount of throttle is all you need.
So where in the air it's hovering, because it's creating enough lift to offset the weight or to balance the weight, underwater, at zero power it's hovering because it's neutrally buoyant. Neutrally buoyant is like the water term for hovering.
Yeah, you don't have to carry your weight. You're there. You're sitting there.
Interesting. Very interesting.
So that was actually so it's very efficient underwater. You sit there until you need to go somewhere.
When are we going to have underwater drone racing? I have to ask.
Such a good question.
I didn't even say. Normally, when I say drone, I put my fingers up because I still haven't adjusted to the word, but. No, I mean... So
think about it. There is a lot of underwater vehicles, and those are, they look like torpedoes,
right.
They have a little propeller in the back. They have their limitations. We just introduced a completely different type of vehicle, which is big propellers.
Right.
People's minds like, oh, big propellers, bad idea. Actually, it's not a bad idea because it goes so slowly, right? You're going a few hundred RPMs. If you had a little one, it would be going a few thousand RPMs. So what happens? Now you're actually a little more efficient. So these big propellers, even though they look like they're going to eat something, they are actually quite efficient underwater.
That's very interesting.
So maybe we should have a race between our vehicle and those traditional ones.
Traditional submersibles, like what was the one from the movie? What was it? Gray Lady Down? Old movie. They had the big submersible that goes down, has a name, I forget. But anyway, so who's sponsoring your work now? You told me that it's been picked up. You're actually sponsored. It's a research project.
Absolutely.
You have students working with you?
So about a year and a half ago, I went to the Navy and met with some of the program managers. And when they saw the video, right, we had one of these initial videos, they really were very impressed.
Right.
So they said, we love it. And obviously, there's paperwork involved. You have to convince them. You have to write up everything. But it was quite easy, I think.
Wow.
Usually you work a lot of, you write a lot of proposals before you can get funding. This was one of the easier ones because of when you have a product, then people can see it, right? They can feel it.
Right. Now that the Navy's involved, now that it's not a private research project that you're doing with students, now that the Navy's funding it, are you able to talk about some of the challenges, some of the hurdles that you're hoping to overcome with, you told me we were supposed to have the helicopter here, and it's parts of it are here. The whole thing isn't here assembled because it's in the middle of an upgrade. So they're bringing it up to a newer revision, which is totally understandable. That's why you know, a lot of my gear in my basement is in pieces. Part of that's because I don't fly very well all the time.
That means we're working with it, right? The fact that it's taking apart, that means you're actually doing things with it.
No, but so it's not together because it's in the middle of an evolutionary step forward. You're evolving. But are you less able to talk about it? Are you less able to be public about where the project's going and what some of the goals might be? Are you now constrained?
I can tell you a few things. So basically, if you see the vehicle, it's tethered, right? So
I noticed the tether. And that was because I read it online, but why don't you tell us?
So right now, for underwater communications, RF will not work underwater. So,
okay.
And it does to a few feet, 1, 2, 3 feet.
Right.
But you don't have a good control. So the idea is to include what is called acoustic communication. Acoustic communication will allow you to talk to the vehicle underwater.
Wow.
So we're implementing that. It's going to take a few months, 6 months. So on before we do that, the only way to talk to the vehicle is through a cable, a tether.
Right.
So that's the only reason we have that cable. Some people think, oh, there's power, there's other things going on. Nothing.
So you're hoping to evolve away from the tether.
Correct.
Long term.
You should be able to let it go and travel some distance, half a mile, go underwater, do its job, come back to the surface and back to you.
Wow. It's freaky to think about. You know, what happens with these things is you get exposed to a new concept or a new idea, and then you let your mind kind of run away, get a little creative with some of the applications might be, and you end up, it's overwhelming sometimes to think about all the different applications that you can apply this technology to. So yeah, one that can fly a half a mile, dip into the water, maneuver around, and then pop back up and return.
You know what?
That's some pretty intense stuff.
And you know, one of the advantages from having that is what I call rapid deployment. If you need to inspect something that's half a mile away, you need to get in a boat, go all the way there, deploy something. That takes time. Half an hour, more.
Right.
Now you can do this in minutes. So
wow.
I think, and you're obviously reducing the number of steps. Just one vehicle can do everything.
Wow. Well, that's interesting. What are some of the biggest, I would imagine a lot of the technology to make this fly in the air was just available because the helicopters themselves, for hobbyists, for commercial users, it's all pretty well developed at this point. And you've been in it for about 3 years? You've been working on this?
Yeah, actually about 2012 we started. It's a little more than that, but yeah.
Okay. So the aerial part is manageable. Taking the aerial system and putting it under, not just on the surface of the water like we've seen some hobbyists do, but actually going underwater where now you have pressure, you know, it's a little more significant. You know, the wetting effect is not just on the surface like if you're sitting in the water. You actually have pressure working on the joints, working on the motors and stuff. What were some of the biggest hurdles?
So obviously you want to keep all the electronics away from the water, right? So we use a pressure vessel. And actually you're going to see later on, I think, actually we have it here. This was one of the first ones that we built. This enclosure, this all, you know, there's some seals in there, and you just bring your wires out through some leads. So this was the original one. We have evolved into different cases that can handle more pressure. But it was a nice work that Marco did here to, and it's obviously to make it neutrally buoyant, you want to make this as small as possible. Right. So small amount of air, so it doesn't come to the surface. It's buoyantly neutral, stays in there. So that was one of the big steps. Actually, it takes time to do something like this, right?
Sure.
Different types of rapid prototyping. This was
I'm trying not to ask you any more questions about it so we can talk to Marco next. The questions are filling my head, but we want to get the guys out here. They've been fed. They've had a chance to chill out a little bit. They're taking a break from their busy school schedule to join us tonight. So why don't we bring out anything else you want to add?
No, that as the conversation goes, maybe we can...
Sure, you're welcome to stay with us and continue to talk. You're welcome to go off to the side and
let's wait for Marco
and watch. Why don't you come on out, Marco? Marco is how do you say your last name? Maya? Maya. So thanks. There's your microphone. Marco is the project manager at your mechanical lab? You're a mechanical engineering, or you're an engineering instructor.
Right now we're calling it the Applied Fluids Lab. Applied
Fluids Lab. Okay, fair enough. That's what I was trying to get at. Because I know there's departments and they all have their labs, and sometimes the labs have specific names.
Yes. So you mentioned the racing, right?
Okay, go ahead.
We would cheat a little bit, right? We would get above the water.
Yeah, right.
Run real fast, and then
drop back in.
We won.
Right. Yeah. So when you were designing this, now you're the project manager. Why don't you tell me first about your responsibilities? Your undergrad degree was what, mechanical?
Mechanical. Yeah.
And your postgraduate, you're in a doctorate program now. So you've established masters. Was that also mechanical?
Well, I'm skipping straight to the PhD, not
okay.
Masters.
Oh, that's interesting. Wow. I didn't know you could do that.
Yeah, apparently you can.
He's good, very good. We can do it.
I stopped at bachelor's. I had enough at that point. I tapped out. But so just face the camera over here so everybody could see you. And so you're doing your PhD in what?
In mechanical engineering.
With a specialty? Are there specialties?
Right now it's called mechanical and aerospace engineering. So they're soon to split that.
Right.
So,
and what's your role in the team as far as being project manager goes?
I lead the team. I design the vehicles, and I take into consideration the findings of every one of the team members. So everybody does their piece of the work. They do their own research. And in the end, we put it all together. And we figure out, okay, this is what the design parameters are.
Right.
This is what we need to do. And then we put it all together. I make a design, and it gets manufactured, and then we go test.
Now, something like this is kind of a complex shape. It's, you know, in 3 dimensions. You've got a clear section down on the bottom here. Right. You've got electrical contacts coming through the pressure vessel. Yeah. Is this designed in the computer with the volume designed to be? Is this designed in 3 dimensions with different analysis being able to be done to volume matches the volume of the water it's going to place to be neutral, that kind of thing?
It was all done in CAD, and this was actually rapid prototype, so we just took it directly from CAD and put it into the machine, and it came out like this.
Oh, so this was machined
to
be like that?
It was printed.
Oh, really?
Yeah.
Wow.
Yeah.
It doesn't look printed.
Looks nice, right?
Yeah.
Yeah.
And you didn't have to do any surface preparation or anything to get it nice like that?
No, I mean,
it doesn't really have any of the
painted it, but you know, that's about it.
It doesn't have any of the manufacturing or the printing lines that you might see.
Well, it's a different kind of printer. It's a much more expensive printer that Rutgers has available.
Oh, you didn't print this at the Apple store at the mall, like I see? Or no, that's the Microsoft store. They have the printer out sometimes.
I have one of those MakerBots printers, and this is way beyond that.
Wow, that's much better quality than anything I've ever seen from a 3D printer.
It's comparable to like injection molding and things like that.
Wow, cool. See, it's amazing.
Yeah.
And then you do the analysis so that the spacing of your fasteners gives you enough clamping pressure so the water pressure can't get in.
This one in specific used the gasket, and some designs use O-rings and so on.
Wow. How many have you built so far? I mean, I've built some of my own equipment, and I've gone through iteration after iteration after iteration to get things exactly the way I want them. So how big is the pile of spare parts? Is it in your apartment? Trunk of your car? His office? I mean, where is it hiding? I know it's out there.
Professor Diez has a pretty big lab. We can fit everything in there.
Right.
But over here, I was pretty generous. This is NV001.
Yeah.
So it's a pretty large fleet that I was planning to build here.
Yeah.
But right now, we're up to the 4th iteration.
Wow.
And we don't have a lot of spare parts. We do what we can with the prototype that we have, and then we learn from it as best we can, even if it's not perfect. Right. And then we jump straight into the next generation, which is kind of what we're doing now.
Yeah, that's a really good point you made there. We try to really learn as much as we can from each prototype before we go to the next one.
Right. And that makes sense also because are you there during the summer also?
Oh, yeah.
Working through this? It's not like in June you guys hang it up and come back in September. I guess
the opposite actually. During the summer is when we are the most productive. Research labs is students don't have classes anymore. They can spend full time.
Oh, that's right. Because you're probably in teaching also at this point, right? You're giving classes?
No. I'm a GA. It's a graduate assistant. There's also the TA, which is the
he has to take classes. So he takes classes during the semester.
Oh, so he's not instructing.
No.
Okay. So I just realized. Could you guys do anything about my transcripts when you go back? To just a couple grades with the eraser? You guys can maybe discuss that in the car. I'll send you a text with fluid mechanics, maybe bring it up to a B.
Listen, once you finish school, grades are not that important anymore. I mean, obviously, you need to get your first job, and, but after that, it's more about how you're able to...
Job performance.
Yes, exactly.
Accomplishments, being able to do things. Yeah. So what would you say have been your personal challenges as project manager you've been tasked with designing this. You know, there must have been a couple of things along the way where you were a little more challenged than you might have liked.
Well, in the beginning, it was basically just myself and Professor Diez, so that was probably the biggest challenge. Just, you know, working on our own before even we had funding. So.
Oh, you were the original.
Yeah.
And this was your senior project? Is that how it started?
Well, it started in 2012 as a senior design project.
Okay.
Like a capstone project. And there was a team on that, and that's when we built the inflatable system.
I didn't realize it was your senior design project. I thought it was a student who did it, left the system, and then you guys picked it up as grad students.
No, yeah, some of us were there since the beginning.
Wow.
He said, I can do this better. We can do better. And that's kind of the mentality you want to see in an engineer, right?
Sure, sure.
We done this much, we can do more.
And then as still part of undergrad, I did this program. It's called J.J. Slade Scholar, which is a research program. You take credits of research. And that's when this prototype was born. So it's not... Go ahead.
No, go ahead. I just saw the footage that Bill had up. I was going to ask you a question about that. Finish what you were saying.
Go ahead. I already forgot.
Bill, run that footage again. Has this been a constant, or is this an old design that you wouldn't see anymore?
Well, he does have a video. I gave Bill a video of the first iteration, which is this one.
This isn't the buoyant one, though.
No, was that one a little heavier? Or?
It was a little heavier because we wanted it to go down.
Okay.
Yeah. So he has that one as well. We did a transition test, and that one was actually, it's that video right there. That one is tetherless, so there's no tether on that one. But, you know, obviously with RF, you have a limitation on the depth that you can go to.
Right.
So that's why in this particular video, we focused on transition in and out of the water.
So that one goes into the water, it sinks.
And then it comes right
and
back
then
out.
Just pops itself back out again.
Now, if we wanted, we could maneuver in the water, but then we might lose the signal.
Oh, okay.
So we didn't try.
And that's this frame that's in the studio with us.
That's right.
That's
this exact frame.
Wow. Okay. So what else do you have to tell us about it? Or is that pretty much it? And you're going to go grab that last slice.
I mean, I like going from iteration to iteration. It's just the things you learn are amazing. The next gen that we're building, it's going to be able to do so much more. So as we get the acoustics working, it's going to be a lot better.
Are you able to talk about how an acoustic control system works, or not really?
Well, we don't create that ourselves, although we do have teams at Rutgers that are very well versed in acoustics, and they'll be able to help us. But you can buy acoustic systems; they're just very pricey. Right?
Oh, I didn't know that. And it's controlling, when you call it an acoustic system, it's using sound?
Yes.
So it's using it as...
pressure waves.
Interesting.
And you have a range. Acoustics have a range underwater, so you cannot go that far.
Right.
You can probably go 20 miles, but you know you're limited by how far you can go.
But it's literally sound.
Yeah.
I mean, pressure waves are just being created by a speaker, like any speaker.
Yeah,
it's a pressure wave. That's what sound is.
It's a transducer that you put underwater that it just vibrates and produces waves.
And it gives the distance that RF just won't be able to do.
And you have fine enough resolution with the sound passing through the water from that system to be able to maintain fine control. Is that system only in the water?
So the problem with acoustics is that you have a lower rate, right?
The bandwidth is lower. So instead of controlling it manually, you'd have to give it commands. And the vehicle would have to be smart enough to know what to do with those commands.
To survive without such a continuous control stream.
Go inspect this mine, and it goes there and inspects the mine and gets back to you.
Oh,
relays images slowly back to you.
So you're not controlling it the way we control it. You're controlling it the way they would control like the Mars rover. Right. They send some basic instructions. It takes it, says I could do this, does its thing, and then whatever the stream of controls runs out.
There's a few seconds delay. That's what the problem is. Acoustics, you have a few seconds delay, and it's very hard to avoid that, right? There's distance, the system has to recognize it. So low rate and some latency.
And there's nothing at Hobby King that's available for you guys that would help you?
We wish.
Nothing?
Yeah.
We're talking...
Huh?
Bind and fly?
Yeah. Bind and
tens
fly.
Of thousands of dollars.
Yeah.
And that's the other point. The acoustic modems are in the $10,000 range.
Yeah, wow.
That's interesting. So that's what makes this vehicle, it will make it very expensive.
Cool.
We'll get there.
Cool. Well, that's a great experience. Yeah. You're bringing a lot to the table when you finally finish your education and go out and get a job.
Yeah,
absolutely. If Professor Diez, if Professor Diez will let you go, he's, you know, it's going to be tough, right?
Usually takes 4 years, but Marco, I think, I don't know,
8.
He did it on camera, so I'm going to have to hold him.
Hold
him to that.
Interesting. Well, congratulations. That's very impressive. Nice to see Rutgers.
Yeah.
Doing great stuff
in
the community. I know, I'm the only one wearing a Rutgers shirt. That's great.
From there, so.
That's okay.
Thank you very much.
Sure. Thank you for coming out. I appreciate it. Who do we have next? We have James Hind.
Oh, that's right.
And I believe James is our software guy who You're the controls guy. He, you can take the microphone. Just have to hold it up a little bit.
Sure.
James is wearing his Goopalini, his cat, from the Scott Norton line. Scott, if you're home watching, he's your guy. So if you probably haven't watched the show because you've been so busy.
Yeah, pretty much.
You haven't
late night at the labs.
You haven't caught on to the wave of enthusiasm that there is out there for Drone Radio Live, which I understand. So you haven't seen Scott with his cap on.
Yeah.
But so you're the controls guy. Just face the camera a little bit so we could all see you.
Okay. Hi.
You could say hello. Is your mom watching?
I don't believe so.
Okay. So what is your role in the project?
Working on control systems for this. So basically flight controllers.
Okay.
I'm sorry, I see the video up there. We have the, I guess, with the traditional, for the common practice with the other quadcopters, it's customary.
You're using a 2.4 gigahertz system, like a hobby controller. Just move over this way a little bit so you stay in the camera. That's fine.
There we go.
You don't do this all the time.
No.
You know, actually, you know that you brought the PAD controller before.
Yeah,
you can say something about that.
Yeah, so traditionally, just with the hobby drones, you're working with a PID controller.
Right.
Whereas we have implemented PID controllers, and as you mentioned before, where you can switch between control schemes, something called gain scheduling, and but with our
gain scheduling, that's a good way to put it.
Yeah, that's the technical term for it.
Right, for different profiles, and some of the flight controllers have that. Gain scheduling. I never heard it called that.
Yeah, well, you were saying as you drop lower, like you lose. So a lot of times when you're operating, these are different operating points for your system. So a lot of times when you're designing a controller, you're designing around specific operating points. And when you leave that operating point, because it's a nonlinear system, your controller is not often designed to. They can't guarantee perfect control in the system. So like when you're losing control, so sometimes they'll use gain scheduling to work around that. So basically, you know, as your different sensors read different things, you can switch different gains of PIDs.
Right.
Whereas that is a temporary solution, but we need something. PIDs are known for, they're perfect for this because they're really fast. And, the tuning is relatively easy when you're out there flying. I know they have a lot of auto-tune.
Right.
Yeah.
Yeah, the auto-tune thing has caught on in the last year or so.
Yeah, that's for sure.
And sometimes it's great, and other times it's not so effective. But it puts you close, and then you just fine-tune it a little bit manually.
Yeah, but for a system like this, because we have the dual medium operation in the air and in the water, it puts a lot of additional constraints on your system that you need to, some things you can't really compensate for with just a traditional gain schedule. We want something that needs to be a little more robust.
When you go from air to water, is it sensing it and switching automatically, or is it a switch on the radio or on the controller?
Well, we have the switch on the controller, but we are implementing automatic switching.
Auto switching.
Yeah. It's all like fluidly moving forward as we're building and building and building. So.
Right. It's the evolutionary process is very quick because you're recognizing milestones that you might have met but are not sufficient to keep going. So you're
a lot of time, you're starting at the bottom, and then like before you even get to the next level, you're like, we could try something different, and then you eventually you build up to the top where now you have the full function.
It's easy to get sidetracked.
Exactly.
So I always have to. That's kind of my job to make sure that we stay with the main parameters, right?
Right. Once you set your parameters, you work towards them specifically, and try not to bring in all the additional complications that might pop up along the way as you're learning and testing.
Yeah,
and stuff.
I get excited because it's a new environment.
Right.
So there's a lot of different controls that haven't been tested for this platform, and so I like to get in there and play around.
So what's your specialty as a student? You're a PhD student also?
Yeah.
Are you also on a strict mechanical engineering path?
I'm electrical engineering.
Oh, you're electrical engineering.
Yeah, specializing in control systems.
Wow. So this is actually my first time bringing students from other departments. Usually, you're mechanical aerospace. And
stay with us in the middle of the set here. So
I'll join you guys for
it. Sure. Come on back.
So it's actually a very interesting concept.
He's got a mic.
Oh, he's got the mic.
For a long time,
we're going to do karaoke later. Hang
you
on.
will have faculties recruit students from the department.
Right.
But in this particular case, we do need people from electrical engineering. So that's why James joined us. So it's kind of like multidisciplinary. We have to identify that. There are things that we shouldn't think that we can do everything. Bring the resources from wherever they're available. So if it's electrical, computer science, whatever it is.
Well, you know what? If you started, like we run multi-rotorforums.com. If you started electrics for drones forums, you would have a lot of traffic because the electrical aspect of these helicopters is the part that trips everybody up when they're getting started. Right. Everyone looks at it and it's very, you know, it's not super intuitive like an airplane when you look at it to understand how it works. But when you look at the motors and the props and the frame, people are like, hey, I bought motors, props, and a frame, and I bought this APM thing. And then it's just like this tires screech across the pavement because the wiring and the batteries is just like, oh, God. I mean, you can hear people's brains ripping apart inside their skulls. So it's the electrical stuff. And the software, in my opinion, the people with the software expertise and the electrical expertise, we were talking about this earlier,
right.
You guys are going to inherit the earth. You're like, we're not worthy, us mechanical types. So
there is room for everyone, right? You know, I still say mechanical aerospace #1. Right?
Someone needs to build it.
Yeah.
And then we can get our hands with.
Well, let me ask you a question. You being the guy that understands the flow of electrons and stuff, to what degree do your control systems mirror our control systems? Are any of the components, are you using Arduino for programming? Are you using, like, is there an APM system in there? Or is it something more advanced than that?
To what degree? So the actual flight controllers themselves, we work with all kinds. We work with APM, we work with Pixhawk, we work with, some high-level controllers.
Right.
And now, but essentially, like, Mission Planner and Darticopter and all those.
Sure.
So, I mean.
Did you start with that? Was the first one? Did you guys just?
That's where everyone starts.
Right. So you always start with an Arduino. And
but you asked specifically if we're actually moving. We're doing custom development, so a lot of programming. We're moving away from the whole PID setup because it's not as useful for us with our applications.
But
interesting.
I would say for mainstream is not needed. What this is giving you is a robustness. So we're going for the robustness part with this, right? If the Navy is going to be using this, you want to make sure that it survives strong, complicated environments. Yeah.
Right.
Rain, seas,
So maybe in the beginning, what you had, as far as systems go, might have been similar to what a high-end hobbyist was using.
Absolutely.
But now you've gone through iterations, you've brought in higher levels of expertise, and you've moved past that, and you're into custom stuff, custom software, and...
yes, expensive controllers, that kind of stuff.
Interesting. Very interesting.
We need to get Lucas.
He's the software guy you're going to talk to.
All right. Oh, I thought Lucas was I thought Lucas was the mechanical guy with the motors and stuff.
He is mechanical.
He does everything.
He does everything. Well,
or at least he says he does.
It's a small team. You guys all have to overlap a little bit. But anyway, well, let's bring Lucas out. Thank you very much for coming.
Thank you for having me.
Sure. Appreciate it. Very interesting stuff. Right. Lucas, come on out.
How are you guys doing?
Very good. Give a little wink to the camera if you want.
There you go.
Anyway, so tell us about your part. We've heard about the design aspects. This is a very impressive 3D printed frame that you've got here. Very lightweight, efficient design, which is always nice to see. We've learned about the electrical systems. Professor Diez has told us a little bit about the history of the projects.
Sure.
What are you doing here, other than eating the pizza and stealing the last mozzarella stick?
There you go.
Sure.
I saw that.
I saw that too.
Yeah.
So I found out about this project through an email professor sent out looking for interns over the summer to work on different projects dealing with programming and computer engineering. And I took him up. I was really excited on it. And it's really just this project that's permeated my life. Like, it changed everything.
You and about 400 million other people. We all commiserate on the website about how it's just, you become obsessive about it.
Exactly. Like,
it's so fascinating.
And that's the kind of people you want to work on this, right?
Sure. No, absolutely.
If you just do it like a side job, no. We want the intense students that...
Like, now, whenever there's any class, I have any projects to do, I always think to myself, how can I apply this to the Naviator? I'm in this software engineering course right now, and I'm thinking, all right, I have to do something with a GUI. I have to do something that's large scale. How can I use my skills to benefit the group?
Right.
What can Marco use? What can benefit Marco? What could benefit the team and help us to make the next generation vehicle better? So for instance, for software engineering, I'm making my own mission planner from scratch with my own GUI to make it personalized for Marco, make it personalized for the vehicle.
Right. Real quick, a GUI, that's GUI, that's a graphic user interface.
Sorry about that.
No, that's all right. I just, because we like to encourage, multi-rotor forums is an interesting site because we've had a lot of very high-level professional media people hanging out at the site trying to learn the finer points of building and flying multi-rotor helicopters.
Sure.
But then we also encourage the beginners to come in and ask questions, take up all of our spare time if they need to in order to get started, because then they pick up the slack and they become the experts and they help the site. So, or they help new people at the site, and it continues to keep the site kind of vibrant. So we're always trying to keep the new people coming up to speed with everybody else. So graphic user interface is the thing that you use on your computer, which has the little sliders and the tabs and stuff so that you can interact with your flight control system to tune it, set it up, customize it, whatever it is that you're doing.
Yeah, it allows the non-programmers to use the program.
That's exactly it. It allows non-programmers to interact with the programming.
Sure, and also another key feature I'm adding to this program is the ability to send these underwater commands that Marco was mentioning before with the acoustics.
Wow.
And actually, I took that upon myself as my capstone. So remember you heard earlier that Marco's capstone, when he did it, at his age, he did this as his initial project. Now my project is doing underwater communications for the Naviator. Because like I said, every project I see now in school, I keep thinking Naviator.
Right.
That's what I like about Lucas.
That's really intense stuff,
But we do have a great support for the communications project. We have a faculty in the Department of Electrical Engineering, Professor Pompelli. He has great ideas on how to do long-distance acoustics. Really breakthrough. Nobody has ever been able to send video 20 miles away. He thinks with his ideas you can do it. So we can have a breakthrough right there and then.
At Rutgers.
There you go.
Hoorah!
I love that you bring in your polo. Your Rutgers polo.
Yeah, I had to. I haven't been down there. My son actually. The other day we cut through New Brunswick. We stopped at Old Man Rafferty's for dinner.
Yes.
We were coming home from. I forget where we were, but we detoured through New Brunswick, stopped at Old Man Rafferty's. We drove through the College Avenue campus, and my son said, "Maybe I'll go to Rutgers."
There you go.
And I thought, that's fine. It's cool. I have a lot of great memories from there.
I love that
campus.
Place. I love that place. We take, actually, when we have visitors and important visitors, we even take them there. We had an astronaut a few years ago. And
you took it? Yeah. You took the Old Man Rafferty's.
He got extra cake. I was like, you guys good
That's
cake.
funny.
Good cakes over there.
Yeah. What I liked about the university itself was that, I grew up in Nutley, New Jersey, which is right outside New York City. So being at Rutgers felt a lot like home because I was in college. The Rutgers College campus was beautiful. Bush campus right across the river was convenient. Everything was there. And at night, if I did my homework, which sometimes I didn't, to be honest.
I'm going to go check your grade.
It had a great environment for, just killing time, which was cool. A lot of colleges don't have that. So New Brunswick was a great town to hang out in. Especially at the Melody, which isn't there anymore. I'm sorry, you missed out.
We got the Laugh Factory now.
Oh, okay. But yeah, it was a great environment.
You're gonna stay in the lab, you don't need to be outside.
Yeah,
of course not.
Yeah, don't be like Bart. But anyway, so the acoustics thing, that's exciting. That's a big challenge. Lag kills everybody's. I mean, we've kind of seen the steps with different systems overcoming lag with wireless HD video. That was a problem because there's so much data being streamed wirelessly that, I mean, you would think, how could you overcome lag? But now they're down to the point where it's almost instantaneous and you can actually use it to control the helicopter in an FPV type thing. So that's great for aerial media people who want to have an HD feed. So that was a hurdle that's been overcome. But what you're talking about is a little different, because you don't have the bandwidth. There's no technology. So you're kind of coming up with solutions to make it do what you want to do, which is exciting.
And you have to remember that when you're underwater, unless you have some video feed, you're not going to be able to see what's going on. So you need to have some sort of autonomy, right? The vehicle has to be able to make decisions on its own. it has to have a mission planner, right? It's going to go some distance and take some pictures, whatever it is. So you're not going to be able to be flying it because you can't really see it. You know, if you're sitting on a boat,
it's true. Right? It's kind of like you have to put your mind in that.
So you got to let it be autonomous, right? Don't fight it. Let it do its thing. You know, you just send some control.
But underwater, you don't have GPS either.
You don't have GPS.
So and you have currents. You have you probably have up and down drafts with the currents. You know, the currents aren't just lateral. So you have vertical motion with the currents. Temperature differences are going to change your buoyancy. So these are all complications that you're not just using a flight control system with 4 basic modes of control. This is real intelligence that has to be built into it to be able to process all this stuff.
The modem has positioning, so the acoustic modem can be used for positioning. You can do, triangulation. What else can you do?
And before you ask, I'm not coming back to do my PhD to work with you guys.
I think we need you.
I was thinking about that.
Are you sure?
I just ruled it out as we were talking.
When I did my PhD in Michigan, I had an office mate who was a prominent lawyer in DC. He says, "I'm done being a lawyer. I want to be an aerospace engineer." So this guy is on late 40s, early 50s, and he switched his life in DC for a PhD in aerospace.
I love the engineering discipline, and a lot of my life is probably typical of a person who's a compulsive problem solver, just by nature. But I am not going back to school.
That is what a good engineer is. So
I would love to go back to school. I actually almost went back for my MBA when I was 30, and my airline career was far enough at that point that I said, let me just keep going. But no, I was just kidding.
We're trying to recruit.
My parents are digging their fingernails into their cushions right now, saying, "Don't go back to school."
Anyway. If you do something that you love, maybe it's worth it.
Yeah. So you're going to graduate.
That's correct.
Just go back. Semester. Yeah, he's a senior right now. He's finishing up his undergrad mechanical engineering.
No. I'm a triple major in math, CS, and computer engineering.
Wow.
Yeah.
What were the 3? Math,
computer science.
Computer science and computer engineering. Wow. Plus, you're doing this project full time.
Right.
Wow. That is that is intense. That's a lot of work.
He spent all Christmas working on this. Everybody's on vacation, and here I have Lucas fully dedicated in the lab.
And you're finishing in 4 years, triple major?
Yeah, I do like 23, 25 credits a semester.
Wow.
So that's how you stay on track.
I'm like, there's another one, like, I'm not worthy. Oh my God, the studio's like...
Lucas is a completely new
Drone Radio Live, right?
We do have very good students that sort of challenge themselves, and that's what Lucas is doing.
Yeah, I was the one
Rutgers.
that recommended James to the program.
There you go.
So what's next for you then, as far as academics go?
Sure. So me and Professor Diez will talk about my options, and I'm hoping that he'll be able to fund me for my master's.
Right.
And either doing computer vision or computer controls.
Wow.
That's right.
Wow, I'm impressed.
He's worth it.
Good for you guys.
So usually when you have a funding like we do have for this project, we get to pay for the students' tuition, they have a salary, a stipend, it's actually, if you're good, it's like Lucas, you get funded.
Wow.
Wow.
I'm just in awe, like I'm speechless. I'm just like, wow. Well, because, as a student, I did a Bachelor of Science, Mechanical Engineering. Pretty garden variety stuff as far as that goes. But even that is a hard course of, it's a hard curriculum to get through.
Yes.
But to do 3 of those at the same time while also doing a project like this, and like, hey, what are we going to do? I'm going to go hang out at the quad and maybe design an acoustic control system that'll go 20 miles. I don't know. Maybe I'll just shoot for 15 miles today and I'll catch Jeopardy at 7 on Channel 5 or something,
No,
that's impressive. Congratulations. You guys are all, I thought we were going to learn about quads, and here I am. Yeah. And here we are. I'm just kind of blown away at the personal. And that's what happens a lot with this stuff, especially in the RC hobby, is you think you're just building an airplane, you think you're just going out to fly helicopters, joining an RC club, and the personal aspect, the friendships, the relationships, end up being so much more than the actual, hey, we'll build a helicopter and go fly it around. So it's,
and you gotta match,
this is typical.
You got to match the right people to the right projects, right? You got to find the passion. You got to work on what you like. If you end up doing things you don't like, then it's not going to work.
Sure.
So I think with the 3 students that you've seen, we have a good match.
Wow. And you're doing great work. I mean, 10 million hits, just a viral. If I said I'm going to bring 3 PhD students together and we're going to manufacture a viral video, and if you were successful, that alone would be an accomplishment, being able to engineer a viral video, because so many people are posting stuff on the internet thinking this is going to go, and it never does.
You know,
if just the viral video were your goal, I'd be impressed. But you're doing so much more. I mean, it's incredible, the project.
Nice. It's exciting. You know, at one point we were competing with the Minions video. You know,
the Minions.
They had like 9 million. We had 10 million. Like, oh.
Did you ever make it to the homepage on YouTube? Did you ever flash on the homepage because of your?
No, did we? I'm
not sure about that, but all the media stations like News 12 New Jersey,
right.
The Rutgers Radio,
right.
Some of those mechanical engineering forums,
right.
Like, they all posted about us or posted our video and shared it on Facebook.
National Geographic is actually going to be filming us next weekend for a new TV show called Machine Impossible.
Wow. Well, they probably won't be quite as professional in operation as we are here at Drone Radio Live, but at least we've prepared you for it.
They are willing to put 2 famous reporters in the pool with the drone.
Really?
Let's see what happens.
To swim with the drone?
Yeah.
Well, the swim with the drone, that's my thing.
So what's next for you? What's the big? Is it the acoustic control? Is that your big hurdle?
Well,
looking forward.
Right now, I'm working on that and the motors right now.
Mm-hmm.
So with the acoustic thing, it's being able to use both RF and acoustic signals, and be able to decide which one's more reliable, which one do you want to persist with, and how to transition between the two of them, which is really important. It helps us to cut the cord and look more professional at the same time, go out in the real environment like the ocean and the waves like you were talking about before.
What are the systems that are used for communications and control with things like submarines? I mean, what does the military use?
Acoustics, very expensive acoustic systems.
To go from a satellite to a submarine, do they relay it through a boat?
They do have buoys.
That's another thing. Their buoys are like, screwed into the ground, and my capstone design is making a smart buoy that's able to go with the vehicle.
Wow.
So you see, by having, using one vehicle, but what if you have 2 vehicles? What if you have 3? You can have one on the surface relaying data to the other one. So you can start swarming, which is kind of an interesting area that we're getting into. Having multiple
because if
vehicles
one can go 20 miles and you have 2, now your reach is 40 miles with a relay through the second one.
And you can start sharing information.
Sure. And you're not limited by the sky. You get to see as well.
Things you can do, right?
Interesting. Wow.
To me, it's a new field. We just opened a new field. Now we can do these operations, and new ideas keep coming every day.
Yeah, I'm just kind of like blown. My mind is kind of like, my mind blown. Seriously, I thought, a helicopter drops into the pool, they swimming around, It's kind of like Adult Swim, but for drones. And this is, I mean, you guys are, like literally from the video that I saw in October, I thought you took a basic quadcopter, waterproofed everything, ran it underwater, like a lot of us probably had wanted to try, but we didn't have a big enough pool. And you had the tether, and you had overcome, I really thought, based on some of the stories, like you talked about, stuff that was around the internet, I thought you had overcome some of the basics of waterproofing, of making a APM system respond underwater and be adaptable to the fluid qualities of water versus air. But, I mean, you guys are way beyond that in terms of what you're incorporating, what you're trying to overcome, things that you're innovating. I mean, I'm like blown away. I really am.
And just this mission planner, you're going to have now GPS in air and underwater navigation. You're going to see both things, air and water navigation in the same GUI. I think it's kind of cool too.
Wow.
Well, change the way you look at it.
It's like in the movies. That's what somebody says. This is like in the movies.
Yeah, no, it really. Yeah, I'm just blown away at how much. You have totally blown my mind because you're so much farther into. I mean, the technology is so much more advanced than what I had originally perceived based on the stuff that I was reading. But that's why you're here. That's why I invited you, because we thought, hey, this is going to be interesting. You guys are obviously educated. You're working diligently. You're funded. And
so now we can do
big things. You delivered. This was awesome.
And you're going to see a lot more. So just keep watching. You're going to see more things coming up.
Well, until it goes classified, we'll keep in touch. And hopefully you'll come back and share with us, or maybe invite us down. We'll bring in some cameras and
maybe we could do something like that.
And see you at the lab, see where you work. That'd be interesting as hell.
Very good.
So, you guys, do anybody participating in multi-rotor forums or not really? Don't have time probably. So normally we ask the guests when they're participating at the website to make themselves available to take questions and stuff. But if anybody has any questions, at the website after watching this. When you're able to put it back in your head and screw the cap back on, it's going to be a couple days for me. But if you have questions, direct them towards me, if you don't mind.
Absolutely.
I'll shoot you an email from time to time. Absolutely. And we'll get people's questions answered. People that are this is going to be archived on YouTube. Okay. The YouTube channel is youtube.com/users/multi-rotor forums with an S. And this episode will be archived. Ask me questions. I'll forward them to Dr. Diez. And, hopefully sometime down the road we'll keep in touch and follow up and see where things are at.
Absolutely.
So water skiing behind it, is that an option or no?
Fishing.
Fishing with it, yeah. We thought about doing it. People come to the website from time to time and they say, hey, I want to fly my bait out over the lake or whatever and drop it in. And so we get that from time to time.
Well, you see, originally started off as an aircraft and then we were able to go in the water. Now we're going to shoot for space.
Yeah, space.
That would be
on that note. All right, why don't you guys come on back out? We'll say thank you all at one time. And you've been watching Drone Radio Live. This is our January 27th, 2016 episode. We have the team, the Naviator team from Rutgers University here. We have Marcos Maya. James Hind. Yep. Lucas Rivera. And Professor Javier Diez, all from Rutgers University. They came up from New Brunswick tonight to speak with us. Thank you very much, guys. I am impressed.
Thank you.
And I'm proud of Rutgers. You guys, what you're doing.
Thank you.
Keep up the good work. Thank you.
Thank you very much.
That's it, Bill. Unless you want to say something. You're good.
Impressive.
Let's fade out. Thank you for watching.
Good night.